Hola, Vale. Hola, Vale. Te estábamos esperando. Vale, ¿me escuchas?
Sí, profe, ya puede cambiar de cuenta.
Bien, re bien. Bueno, vale. Yo no me acuerdo qué era lo que estábamos hablando. Era algo de aquí, ¿no? No me acuerdo qué era.
Sí, profe.
Era algo de reemplazar acá, ¿sí o no? Yo no me acuerdo qué era. ¿Tú te acuerdas qué era? Yo no me acuerdo qué era.
Lo del paréntesis.
Ah, ¿cómo no? Sí, señora. Ya me acordé. Ok, al reemplazar aquí, ha de ser aquí negativo 10 al cuadrado, paréntesis, ¿no? Y aquí 36 al cuadrado. ¿Por qué es importante? Porque si no le pones el paréntesis, lo que va a entender la calculadora es 10 al cuadrado y luego menos. Entonces te queda un menos. Aquí hay una resta. 36 al cuadrado menos 100 al cuadrado. Quedó muy por debajo de lo que era. Hay que poner el paréntesis. ¿Listo? El orden de operaciones importa, mi niña. Entonces, ¿esta respuesta sí es la que es o no?
No, da 37.4.
Ah, ok, bueno, listo. Entonces corrijámoslo. 37.4. Alguien dijo eso en el chat, ¿cierto? Alguien dijo eso. Y todos los demás dijeron
Creo que
este,
fue
¿cierto?
Dani.
¿Dani? Ok, mira, Dani tenía razón. 37.4. Ok. Vale, mi niña, muchísimas gracias. Muy bien que te hayas dado cuenta de eso. Muy bien, mi niña, muchas gracias. All right, we're going to continue with the questionnaire then. And this was the end of question B and question C, right? No, A and B, right. But now we're going to continue with question C and the question D. Now, if you take a look at the question, if you read it, you're going to notice that for question C, they are asking us to find rectangular coordinates for another location. The location is the US cellular field. That is the location. All right, so where is that in our map? Where is that in our map? It's right here. Right here. Look at this. Where's my map? Here. Let me erase all of these. We don't care about these. This is for the previous question, so we can erase all of these. You know what? Let's just do it again. There, right? So they're asking us to find this, the US cellular field, which is right here in the 35th Street, right? That's the place, right? Okay, so what are the coordinates for that one? Remember, this is a plane, right? This is a Cartesian plane. This is the line for the y-axis. Of course, my line will not be straight because I'm doing this by poles, y, and this one for x. Again, of course, this is a not straight line because I'm doing it with my poles, right? So we are looking for these coordinates, these ones. A little bit, again, a little bit to the left, here x, and a little bit to the right, a little bit down, right? A little bit down, a little bit to the left, and a little bit down. All right, so what are those coordinates? For that, we're going to have to read the information. Look, US cellular field is located at 35th and Princeton. This is just the address. Again, this is just the address. But this gives us the information we need, which is 3 blocks west. All right, so we need to move. Again, we need to move. We read. We need to move 3 blocks west, right? 3 blocks west. This is a 3. And 35 blocks south. So 35 blocks south. This is a 35, right? 35. 35, not 36, 35. All right. So again, what did you guys think are the coordinates of that point? Tell me in the chat, please. Don't forget about the negatives. Tell me in the chat, please. Okay, we have some answers now. All right, keep them coming, please. Keep them coming. Just give it a try, guys. Give it a try. Whatever you think is the answer, give it a try. All right, beautiful, guys. All right, so you're saying the answer is -3, comma, -35. Beautiful. I think you guys learned from this first exercise. Beautiful, guys. Nice job. All right, this is a correct answer. Remember, 3 to the left, right? That means -3, and 3 down, that means -35. Sorry, 35 down, right? So -35. Beautiful. These are the, again, rectangular coordinates. Look at that. Write the location of these using rectangular coordinates. That is the first question. Beautiful. You got it. Now for the second one, write the location of US cellular field. Again, US cellular field is the one from question C. But in this one, we need to use polar coordinates. Of course, the angle theta will be in degrees. In other words, what we have to do is come back to our two equations. R right here and theta right here, right? Just that. Just that. That's all we have to do. So, guys, go ahead and change these values and tell me what are the new values for R and theta. And that's it. We did it. Once you have done that, we are done. I'm gonna give you time to finish this question. All right, guys. I'm gonna mute myself and give you time. In case you're thinking about it, yeah, go ahead and write down in the chat the answer. Please write down in the chat the answer so that I can write it here. Okay, all right, we have some answers. Beautiful. Okay. All right, we're gonna begin with the first thing, which is Cesar saying, "Hey, Mister, sorry, I'm having bad connection." Cesar, don't worry, brother. Don't worry. I know you are a good student. Don't worry. I know if you leave the meeting or you arrive late or I don't know, you cannot answer, whatever. I know it is because you're having difficulties. Just make sure whenever the class is done, you go back and look at the recording, all right? Don't worry about it, brother. Don't worry about it. All right, you guys are saying the answer is 35.1, comma, 265 degrees. And look at that. You even put the little circle for degrees. Thank you, guys. How about that? I think you guys are good. I think you guys are really, really good. You are prepared for the exam. Oh, actividad significativa de cierre. Ok. Experiencia significativa de cierre. The exam, right? Beautiful, guys. All right. That finishes question number 2. This is the question number 2, right? We are done with this. We are done with the question number 2. All right. Let's jump then into question number 3. And just like we did with the previous questions, what I want you to do, guys, is to please tell me, what is the exercise talking about? That is what I want you to do, all right? I'm going to select one of you to please explain us what is the exercise about. Go ahead and read it, please. Go ahead and read the question. You good? Are you done now? All right, cool, beautiful. So let's see. Let's hear it from someone who I haven't heard today. Let's do Aleja Rico. Aleja. Hello, Aleja.
Hi, mister.
How you doing? You good?
Yes,
Beautiful, Alejita. Please, can you explain us what is the exercise 3 about?
it's about a hurricane
Okay.
and what it cost, basically.
Uh,
And the data, it shows the time and when how many major huracanes, I don't know how to
Hurricanes.
say, yes,
Hurricanes.
happened that year in the USA.
Alejita, you are great. Thank you. Appreciate it, Aleja. Pretty good. Pretty good. You are correct, Aleja. Exercise number 3 is giving us some information, right? Some data. So that data, the table that you can see there, the table that you can see there is a bunch of data recollected from 1920. Let me just like this. From 1921 all the way to 2000, right? So every decade, 10 years, every decade, we or these people counted the amount of hurricanes in the United States. So, for example, from 1921 to 1930, we that people got 5 hurricanes, right? And so on and so forth. All right. So that is the information, right? That is the information. Now, let's look at the question. Question number 1. Question number 1. Here. Use a focus camera. Thank you. Use a graphing utility. In other words, your calculator to draw a scatter plot diagram for the data. So plot it, guys. It is your turn. I want you guys to go ahead and take out the calculator and plot this data. Show me the scatter plot, please. At the end of this, I'm going to ask you to please show me the calculator. If you don't have a calculator, remember, you can always download. Wait, you can always download, right, the emulator using your cell phone. It's a good idea. Of course, we cannot do it in the school, but we're not in the school, right? Go ahead and plot the points and you'll let me know. I'm going to do that as well. A little bit bigger. I think I can do this a little bit bigger. Uh-huh. Better. All right, you guys done? All right, I can see David Castro. Thank you, brother. Also Alejita. Wow. All right. Look, David, you can probably do better. Thank you, Lau and Sola. You can probably do better by changing the window. All right. Change the view, brother. Okay. Show me the graph, please. Once you're done, show me the window, please. Vale Moreno, great. Juli, you can change the window, right? Try to look at the points a little bit wider. Try the window. Try to change the window, please. Vega, brother, you froze. I couldn't see. Sorry. You are correct, dude. That is a great view. Thank you. Samuel, Samuel, I think you can see the points, but if you change the view, you can see the points better, right? So try to do that. Try to change the points, all right? The window. Try to change the window. You know how to do that or not? All right, cool. All right, all right. Better view, right, Castro? That's a better view, right? That's a better view, right, Juli? But look, Juli, let me ask you something. Let me ask you something. What type of graph do you think you just did right there? At scatter plots, so points only, or a line graph, so points and lines? What did you do? Because I can see some lines, right? I can see some lines joining the points, right? No? You deleted the lines. I couldn't see it now. You deleted the lines. I don't know why that happened, Juli. Sorry. I don't know why that happened. Samuel, you were showing it to me, but I couldn't see it. Sorry, brother. Who else? Somebody else? Felipe. How about you, brother? Vale. Danny. Marino. Marino, look. You can try to change the window, right? Change the view. And get a better view for the point. Samuel, that is a perfect view. Thank you, brother. All right, Brian, let me see it. Same, Brian. Look, I think the points are too close to each other, right? So you can change the window, right? If you go to window, try to change the view. Make them a little bit wider, bigger. Dani Valentina and Pipe Martinez. How about you two guys? You've done?
Mister, I'm in the like downloading the emulator
Emulator. All right.
for
Okay,
my
Pipe.
PC.
Beautiful. Don't worry about it then, brother. Don't worry about it then. How about you, Danny? About to finish?
Profe, me pasó lo mismo que a Felipe, o sea, lo estoy descargando.
All right. It's okay, Danny. Get it. It's okay. All right. So we're going to give you some time, but in the meantime, I'm going to have to move on with the rest. All right, guys? All right. So if you did the correct exercise, you should get something like this, which you did, right? Of course. Maybe you don't have the same points in the same positions. And the reason is because you have a different window than mine. Look, these are my maximums and minimums on scale for X and for Y. These are the ones that I chosen, right? You may have chosen different ones, right? Okay, beautiful. So now we have the points. All right, we did the first one. Use a graphic utility to draw a scatter plot. Let me just change to this configuration better. There. All right, let's jump into question B. Use a graphic utility. Again, graphic utility is a fancy word for calculator. So use your calculator to find the cubic function that models the relation. So what we are doing right here is a model, right? We are modeling the data, but we have to do a cubic function. So if we go to statistics, again, calculate, statistics calculate, we have to scroll down until we find cubic regression. This one, cubic reg, right? I want you to guys do the same, please. I want you to do the same, please. Here, enter list 1, list 2, frequency, all of that is correct, and then just calculate. Bow. After a while, we get the information. Again, some of you may not have the R2, all right? Some of you may not have the R2. That is okay. That is okay. We are not asking for any R's. Remember, the values that we care are the Y, so the main function. And as you can see, look, the main function is telling us already. This is a cubic function, right? Because the maximum exponent is 3. So this is a cubic function, degree 3, right? And we have the values of A, this one, B, this one, C, this one, and D. So what I want you to do, please, guys, write down this function, but round it to just 1. Round it to just 1 decimal, please. Write down this function in a piece of paper or maybe in your notebook, hopefully in your notebook, using just 1 decimal for each of the variables, all right? 1 decimal for each of the variables. Remember, we have A, B, C, and D. These are the values, right? So just 1 decimal, please. I'm gonna give you some times, some time, sometimes, sometime. All right, this will be. Write down the function, right? Write down the function. I'm doing the same here in the board. I'm gonna show you what is my result, and we can compare, right? If you get the same that I did. There. All right, I'm done. All right, ready? Are you done, guys, or not? Do you need more time? You need to write down this function. Write down the function with the values A, B, C, and D, rounded to just 1 decimal. You done? Okay, Lau is done. Who else? Lau Botero is done. Who else? Who else? Okay, Moreno, Lau Anzola, Juli. All right, thank you, guys. Brian as well. Vale as well. Somebody else, please. Come on, guys. We need to round these values, all right? Round the values. 1 decimal. Show me with a thumbs up if you're done. Aleja Rico as well. All right, Nico, Vega. All right, so I'm going to show the answer now. Here is what I got. Let me increase the size of the board there. This is what I got. Tell me, did you get the same answer or not? 0.2 x cubed minus 2.3 x squared plus 9.3 x minus 2.2. Did you get the same answer? Yes or no? All right, cool, beautiful. I can see a lot of these. All right, beautiful. Thank you, guys. All right, so we have our model. This is the cubic function that best models the points. Now, did you graph that function or not in the calculator? I didn't ask you, but did you do it or not? Did you do it or not? No? All right. If you do so, if you graph the
Mr.
function.
Brian is having internet problems.
Who, brother? Who?
Brian.
Brian, okay. Thank you. Thank you, David. Thank you. If you plot this, if you graph the function, look, let me show you how you graph this. You go to y equal, right? And in here you can write the function, right? The function was 0.2 x cubed, so x, what is the x? X elevated to the 3, there, x cubed, right? And then, I said 2.0, it was 0.2. 0, no, 0.2, there, x cubed. Then minus 2.3, so minus 2.3 x squared, which is here. Nope. No! Okay, I'm gonna have to start again. 0.2 x to the 3, there. Minus 2.3 x to the 2, there. Plus 9.3 x, right? And then minus 2.2, right? Look at that. If we put the function in the calculator and then we press graph, look at what is going to happen. After a while, the function is going to appear. Did I do it wrong or what? Did you get the same that I did or what?
Yes, mister, I get the same.
Did you get the same? All right, so maybe my points are wrong. I don't know what happened. All right, maybe my points are wrong. I don't know what happened. All right, let's take a look at the points. Let's go to stat, edit. 1, 2, 3, 4, 5, 6, 7, 8, and did you get these ones the same or not? The same in list 2. 5, 8, 10, 8, 6, 4, 5, 5. The same? Okay, no, so the plot is fine. And the function, did you write the same function that I did or not? 0.2 x cubed, oof. Minus 2.3 x cubed is x squared, plus 9.3 x, minus 2.2. Everything is fine, right? Everything is fine. So look at that. If we graph this, the beginning of the function is a cubic function. Then the rest is not really, right? Pasa un momentico al español. Este es un buen análisis que hacer. Este de acá es un buen análisis. Porque lo que está pasando es que al decir que los puntos se comportaban de manera cúbica. Tomás, no, profe, qué pena, el Wi-Fi no me dejaba entrar otra vez. No, Tomás, no te angusties, entiendo, papá, tranquilo. Al decir que los puntos se conforman de manera cúbica, estamos teniendo que esta sería la función más cercana a esos puntos. No hay otra. Esa es la función más cercana a esos puntos. Esa de ahí. Entonces, esta función nos sirve para modelar por ahí comportamiento desde aquí abajito, desde el primer valor, por ahí hasta el tercero. Pero la verdad que no nos sirve de ahí para adelante. Porque mira que se aleja mucho. Si cambiamos la vista. A ver, cambiamos la vista en
Profe.
Sí, papá.
Ahí abajo de donde dice ecuación, te pone como unos números. No, a la derecha de la calculadora. Ahí dice
Derecha,
en X,
calculadora,
0, 1.
X.
Ahí esa página,
Aquí.
como eso. No, ahí, perfecto.
Sí.
Debajo de Y1 te pone unos valores como que no concuerdan con nada de la ecuación, ¿no? En Y1.
Sí, ¿cierto?
Y eso debe ser lo que está graficando la línea.
¿Y por qué nos quedó así mucha estadística? Venga, hagamos otra vez. Calcular. Quadratic cubic reg. Aquí está, cubic regression. You can see calculate. Lista 1, lista 2. Ahí están los valores. Eso nos quedó bien, ¿sí o no? ¿Será que el error que tuvimos? Porque mira, ok, a ustedes no les aparece este R2, pero a mí sí, listo. Yo les cuento por encima qué es el R2. El R2 es una medida que dice qué tan cerca está mi función a mis puntos. Y es una medida, entre más cercana esté a 1, mejor funciona la función. Sí, mejor modela la función. O sea, es una muy buena función. Este es 0.9. O sea que debería esta función ser muy buena. Pero cuando la ponemos en la calculadora ya parece que no funciona. Mira, ahí esa función de ahí. Yo creo que me di cuenta cuál es el error. ¿Alguno de ustedes piensa por qué? ¿Por qué pudo haber pasado eso o no? ¿Alguna idea? ¿No? ¿Ninguna? Ok, vuelvo y le repito. La
Se
calculadora
debe
dice
ser
que
elevado
esta
a la
función
3,
debería
¿no?
ser perfecta, casi, casi perfecta, pero cuando la graficamos, pues no. ¿Qué dice Salva?
Se debe ser elevado a la 3, ¿no, profe? Ah,
C
no.
elevado a la 3. No, mira, C está C por X, o sea, C y nada más. C acompañado de X a la 1. Voy a ver si lo hicimos bien. Sí, aquí está 9.3, X a la 1. ¿No? ¿Nadie se da cuenta del error? Ok, puede que no sea el error, pero yo tengo una teoría. Ahorita la probamos. Redondeamos a un decimal. Redondeemos a 3. A ver cómo cambia la cosa, ¿listo? Redondemos a 3 decimales, a ver si eso nos da una mejor precisión de la gráfica. ¿Ok? Ok, a Juli ya le dio. ¿Con cuántos decimales pusiste, mi niña? ¿3 decimales? Ok, parece que 2 decimales. Ni siquiera 3, solo 2 decimales. Ok, vamos a hacerlo con 3 a ver si eso mejora. ¿Listo? Yo le dije con 3, ya empecé a hacerlo con 3. Voy a ir poniéndolos en el tablero, ustedes también, muchachos. ¿Listo? Redondeenme todos esos numeritos a 3 y esa es la función que ponemos en la calculadora. A ver. Quito esto, quito esto, quito esto y quito esto. Ok, este es negativo. Entonces, primero me da 0.1, 2, 3, 1, 5, 9. Están redondeando, ¿cierto? Y los pueden meter de una vez en la calculadora si quieren. 2.32. 3 decimales, ¿listo? 3 decimales. Y veamos si les quedó igual que a mí o no. This is what I got. Did you get the same? 0.159 x cubed, right? Minus 2.32, 0, sure, but 32x squared plus 9.33, again, 0, but whatever, x, and then minus 2.214. Did you get the same or not? Beautiful, all right. So now let's do this in the calculator. Let's graph that one. Let's graph that in the calculator. Let's see if that changes anything at all. Right, so we go to y equal. We're gonna have to clear this one and write it from 0. So we have, what was that? 0.159. 0.159 x to the 3. Right. Oy. To the 3. Minus 2.32 minus 2.32 x squared. And then plus 9.33 plus 9 point, wait, 9. Ah, I have to do it again. No. A ver. 0.159 x al cubo. Cuando le doy borrar aquí, me borra todo. No le puedo tener, no puedo tener errores. Negativo 2.32 menos 2.32 x al cuadrado. Vamos con calmita, no la vaya a embarrar otra vez. Vamos con calmita. 9.33 x. La embarré otra vez.
Profe, ahí te faltó el más.
Sí, señor. Gracias, papá.
Pero solo dale del y ya.
Del. No me sirve. Ah, me regreso acá.
Párate sobre la X y ya.
Me paro sobre la X.
O sea,
Aquí.
párate sobre lo que quieras borrar.
Me paro sobre lo que quiero borrar. Pues quiero borrar esto. Ok, del. Ah, quiero borrar todo esto. Ok, entiendo, del. Ay, jue madre, me borré un 3 también. Bueno, no pasa nada. Elevado a la 3. Gracias, Lau. ¿Qué seguía, Lau?
Profe, es
Nada.
elevado al
Es
lado.
elevado a la 2.
Ah. Ok, ahí voy. Ya poquitos. Aquí, 2. ¿Sólido? Bien, listo, vamos bien. 9.33 más 9.33x. Ok, sólido, vamos bien. Sí, listo. Y luego menos 2.14. Menos 2.14. ¿Bien? ¿Listo? ¿Está bien ahora sí? No, 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 no. 2.2. Ay, quieto, papá. Quieto, quieto, quieto. No la voy a embarrar. 2.214. Ahora sí. Fue madre. Ok, momento de la verdad. Vamos a ver. Bien, 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 bien. Ok, 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 ok. Mucho mejor, ¿no? Mucho mejor, ¿cierto o no? Seguramente si hubiéramos elegido más decimales en vez de 3, unos 5 decimales, nos hubiera quedado mejor. ¿Sí o no, mis niños? Ok, eso se llama precisión, ¿está bien? Entre más decimales cojamos, más precisión hay a la hora del resultado. No quería yo hacer esto, honesta, no planeé yo esto, me salió pues improvisadísimo, pero bacano que puedo mostrarles que hay un error grande si uno elige solo un decimal a elegir varios decimales. Al elegir mejores decimales, más decimales, perdón, pues nos aparece la gráfica un poquito más acomodadita, ¿sí o no? Ok, un par de cositas para antes de que sigamos. Miren, nótense, mis niños, que hay punticos que no coge la gráfica, ¿no? Por ejemplo, a ver, este punto de aquí, la gráfica no lo coge. Este punto aquí, la gráfica no lo coge. De hecho, hay otros puntos que la gráfica solo medio toca. Mira, este punto acá lo está ahí tocando en una esquina y el de aquí también lo está medio tocando en una esquina. Eso significa que la función no modela de manera perfecta nuestros datos, pero no significa que sea una mala función. De hecho, es muy buena la función porque mira que pasa por varios de los puntos, al menos los toca a varios. Es una muy buena función. Esa es la idea de modelar, muchachos. Esa de ahí es la idea de modelar. Tratar de coger la mayor cantidad de punticos en una función. Vamos bien hasta ahí, mis niños. ¿A quiénes les quedó la misma gráfica que a mí? Ok, perfecto, mis niños. Pues les digo, si hay un tema que aprendamos en noveno, es este, tiene que ser modelar. Esto lo vamos a usar para décimo y once, ¿listo? All right, let's continue with English. Let's continue in English. All right, let's continue with the next question. So, use a graphing utility. We did this one, right? Models the relation. We did this one. We did it. Let's go with question C. Use the model found in part B. In other words, use the equation. So use that equation, right? Here. To predict the number of major hurricanes that struck the United States between 1961 and 1960. Look, in 1970. Look, the question is asking us to predict, right? If we look at the table, what is the amount of hurricanes between this amount of time, between these years, 1961 and 1970? Okay, 6. Thank you, Alba. There were precisely 6 hurricanes. All right. But if we use the model, what this question is asking us to do is this. Here in red. This is 1, right? This is 1, 2, 3, 4, 5, 6, right? I did on a scale of 1 for this reason, right? So we're being asked to do the number 5, right? 1961 to 1970. This is the number 5 in X, right? So if we go back, we are looking for this question. What is the exact point for the function here? So in Y, how much is that in Y? It's going to be a little bit bigger, right? It's about there, about that. It's about 6 point something, right? That is called a prediction, using the function to find the value. For that, we need the calculator again. So, guys, here in the graph, what I want you to do, guys, is to please go to calculate. Look, it is on top of the key trace, right? You need to do second trace. That access to calculate. All right? That access to calculate. And here we can calculate things. We can calculate values or zeros, maximum and minimums. We can calculate a lot of things. Right now, for this question, since the question is asking us to predict the value in this years, 1961 and 1970, what the question is asking us to do is to find the value when x equals 5. Why 5? Well, because that is 1961 to 1970. That is 5. All right? So here, we're going to do calculate. We're going to press 1, the value, right? We're going to calculate a value. And in here, as you can see, the calculator is asking you for a value in x. We know the value for x is 5, so we just press 5. Enter, and after a while, the calculator will give you the answer. 6.3. Remember we said it was 6 point something? Well, it was 6.3 for me. Was the same for you guys? All right, cool. So what is this? Paso un momentico al español. Recordemos. El valor preciso es 6. Eso fue lo que pasó. En el quinto año, ¿no? En la quinta década, o sea, de 1961 a 1970, la quinta década, pasaron 6 huracanes. Pero si usamos el modelo, encontramos que el modelo predice que debieron haber habido 6.3. O sea, en realidad no es un modelo tan malo. Mira que casi le pegamos. No es un modelo tan malo. Esa sería la respuesta del C. 6.3. You guys are writing these answers, right? In the notebook or somewhere. Right? Okay, cool. Beautiful. Let's continue with D. I want you to read this question, please. Go ahead and read the question. And I'm going to ask one of you again to tell me what did you think about the question. Please read it. Read the question. I'm going to give you some time. Are we good? Did you finish? You finish or not, guys? Come on. Show me a thumbs up or something. Thank you, Castro. Thank you, Marino. All right. All right, Nico, I'll wait for you, all right? I'll wait for you. All right, let's do this. I want to hear it from Marino, my man, brother. Can you please explain us what is this? What is the question about?
Like to an estimate.
Like an estimate, right? We need to estimate.
Yes.
Sure, but what do we need to estimate about?
The strike of hurricanes between the 2001 and 2010.
Beautiful, Marino, you are correct. But also, at the end, the real question is this one. Does your result appear to agree with what the scientists believe, right? So, Marino,
Okay.
what are the scientists believing?
That in between 2001 and 2010, the number of hurricanes are going to increase.
All right, okay. That is going to increase, right? So let's do that. Thank you, Marino. All right, let's do that using our calculator. Let's predict the future. Now, we will have a couple of each. Let me see one thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look, we are looking for 2001 and 2010, right? That will be the number 9 in X for us, right? It will be the next decade, which is number 9 in X, right? So what we need to do is make sure here, 9. So just from our graph, just from the graph, something like that, right? It looks like things are going to increase. That's what it looks like, right? That is what it looks like. But let's find out. Nonetheless, let's find out. We go to, again, second trace, calculate. We're going to calculate a value. And in here, we're going to press the number 9. Again, why 9? Well, because number 9 will be the next decade. Look, we finish the table at number 8. The next decade will be at number 9. So we just press enter and we get the results. According to our function, we will have exactly 9, or not exactly, around 9.7 hurricanes. Man, that is a lot of hurricanes. A lot. Would you believe this? Man, that sucks. 9.7. Poor people, right? Poor people. A lot of damages, a lot of money lost, a lot of dead people. That is just sad, right? But this is called prediction. And why do we predict? Because we want to know things in the future. This modeling could help people in the United States for the future. So if you know 9 hurricanes are gonna come, then that day maybe that is a good year to just don't be in the United States. You know, go take some vacations in Paris or some other place. All right. Okay, that is the end, guys, for question D. Thank you. So at the end, does your result appear to agree with what the scientists believe? Again, in the chat, please, guys, tell me. Do we agree with what the scientists believe? Yes or no? In the chat, please. Agree, agreed, yes, yes, agreed, yes. All right. Yes, we agree with what the scientists believe. All right. The scientists believe that this thing is going to continue, and it looks like it will. All right. Beautiful. Guys, let's jump into question number 4. Look at these. Look at this. Another table. This is also another exercise for modeling. And we are going to take things a step further. I want you guys. Let me change to this camera. Look, for question number 3, I kind of help you. I guide you. Right? I guide you to find the model. I guide you to plot it, right? To change the view, right? I guide you. But for question number 4, I am not. I will do the exercise myself without showing you anything. And then we will compare answers. Guys, I want you to do every single step in question 4. Look, every single point here. Do point A, do point B, point C, and point D. Yes, do all of these. Write these answers in your notebook. Write the answers in the notebook. I will do the same. And then we will compare. Correct, guys? Let's get to it. I'm not gonna show you my calculator. How are you doing, guys? You okay? All right. Okay, cool. Remember, you're doing this alone, but if you have any doubts or maybe you don't remember something, you can always ask me, all right? I'm here, guys. I'm here. Guys, look what I found. Guys, look what I found. I have forgotten about this, but look at what I found. Okay, so I'm doing the qubit regression already, right? And this step requires me to put this one, this two. Cool. If I press calculate, I'm gonna have the regression, right? The values A, B, C, and D, right? And then I have to write those values in a piece of paper and then write them down in y equal, right? That takes time. Look at this. You can go to store reg equation. Here it says store regression equation. So the regression equation that they will give us, this calculator can store it already. So if you go there and you press bars, look at this. This is the key, bars. Right? So we're gonna tell in which variable we want the calculator to store the equation so that we don't have to write it down nowhere. Look at this, bars. We're gonna move to the right to y variables. Look, y variables, right? To the left, right? To the right, sorry, to the right. Y variables. And then function. Select the y1. Again, all I did was select function. From here, y1. And look at that. The calculator is going to store the equation in the y1. If we press calculate, sure, it will give us the information. I'm not gonna show you. I'm not gonna show you, right? But if we go to if we press y equal, it's already there. Look, it's already there. I'm not gonna show you, but wait, it's already there. Look, it's already there. I'm not gonna show you, but look, 2 point something x cube. It's already there. Hi, Danny, the class is over. No, all right. Man, the time flies when you're having fun, right? I'm sorry, guys. All right, look, guys. I'm gonna start recording here, and let me just say goodbye to you so that you can leave.